Okay, Newton's bucket. In 1687, Newton published the Principia, and it contained the laws of motion. It was an outstanding work of theoretical physics because from the experiments that he did, he derived three laws. The first law of motion, called the law of inertia, is that a body in motion tends to stay in motion unless some force acts on it. The second law says that the force that is exerted on an object, or excuse me, on a mass, produces an acceleration according to F equals ma. So the third law is action-reaction, which says that when one force acts on another object, the other object produces the same force in the opposite direction. So there is a coupling of forces. Those are three laws of motion which form the basis of almost all of the physics that was produced after that by future physicists. All right, so we have these three laws of motion, and the question is, where do they apply?
Hey, real quick, sorry to interrupt. As Bennett's going through this, I got, if you check the purple pill and you want to see graphics of what he's talking about with the equations and the bucket as he's walking through it all, you can just follow along because he's about to go through, what he's about to go through is like the very fundamental and important. So anyway, please continue.
Okay, Newton's bucket. Well, first of all, the question is, where do the laws apply? Newton did the experiment in a laboratory. So he did this in what we call the lab frame or the earth frame at rest. NASA calls it the ECEF, Earth-Centered, Earth-Fixed Frame. Okay, so that's, if you're sitting at your desk right now, sitting watching the screen, then you're in the earth frame because you're at rest with respect to the earth's surface. And that's what the lab frame means. So he knew that his laws were obeyed in the lab frame because he did all the experiments in the lab frame. But then he did an experiment.
In this, Dr. Bennett, Newton assumed that all space was fixed. That's why he was using this frame of reference as the value. Am I getting that right?
All space is fixed? Oh, yeah. You mean, no, you're right, but the way you should phrase it is all reference frames are equivalent. All right?
Thank you. Yeah.
That's the way to state it. In other words, no matter where you are in the universe, if you applied Newton's laws, the three laws that I just described, that they would be valid. So he assumed that there was a universal application of his laws. So in the lab, he took a bucket of water, suspended it from a rope, twisted it so that when he released it, it would spin. When you first release the bucket, the water is at rest because there has to be friction or viscosity between the wood of the bucket and the water. So when you release the bucket will spin, but the water will lag behind. But eventually it catches up because with the friction, the water will eventually rotate and it will form a vortex, a depression in the surface of the water. You can all do this, and I'm sure you can all do it in your imagination. You can imagine if you spin even a cup of water, you can see that a whirlpool will form, and the center of the water will be at a lower level than the edges. And the reason for that is centripetal centrifugal force, part of Newton's law predicts the F equals ma part, predicts that the water will be subjected to a rotation, and that rotation will produce a force that depends on the mass of the water, the distance to the center squared, which is the radius, and the angular frequency, which is basically it's the RPM, the frequency of rotation. So the faster you rotate it, the bigger the radius and the bigger the mass, the more force there will be trying to fling the water away from the center. That's what a centrifugal force is. And so he observed this in the lab and he said, well, it's working. I applied the centrifugal force law to the water in the bucket, and it's doing what I predict from the law. He then said, suppose I were on the bucket and observed the same experiment. So here's where you have to do a thought experiment. Suppose Newton is watching a bucket spinning clockwise in the laboratory. Well, if you were on the bucket firmly attached to the side, you could call that the position of a bucketeer, someone on the bucket. That person would be fixed, and he would see Newton rotating counterclockwise. In fact, he would see the whole lab rotating clockwise because he can't tell on the bucket whether he's rotating or the lab is rotating. But as far as he's concerned, the bucket is at rest, and it's Newton that is rotating counterclockwise. It's important that
did you guys catch that? So what he's saying is, like, when you're away from the bucket, you can see the bucket spin, but when you're attached, quote unquote, to the bucket, it's hard to differentiate what's actually in motion, because when you're attached to the bucket, it doesn't seem like the bucket is spinning. You just see everything, your environment spinning. Go ahead, Doctor.
In fact, relativity says that you can't tell which one is rotating by measurement. You can't tell by measuring how fast Newton is spinning as seen from the bucket, or how fast the bucket is rotating compared to Newton. In fact, they're equal and opposite. So measurement, that is kinematics, will not tell you which one is at rest. But we're using dynamics now. We're using the laws of physics, F equals ma, and the centrifugal force law to try and see if the laws of physics do also are also valid on the bucket. So we had the water rotating at the same speed as the bucket. So relative to the bucket, the water is at rest. In other words, if you were on the bucket, the water would not be rotating. You would see Newton rotating. You'd see the whole world around you rotating, but the water wouldn't be rotating because that's part of the bucket. So if you apply Newton's law to the stationary water, the calm water in the bucket, as seen by the person on the bucket, you would predict that there's no centrifugal force. Why? Because one of the things that is required is that there be a velocity to the water. Remember, the centrifugal force law requires the multiplication of the mass times the radius squared times the frequency of rotation. There is no frequency of rotation on the bucket because the water is stationary with respect to the bucket. So the bucketeer predicts that there is no centrifugal force. But when we do the measurement, we see that there is a vortex. There is a parabola, actually, formed on the surface of the water. And that's contrary to what Newton's law predicts if you're on the bucket. So Newton was puzzled by this, and so was someone named Ernst Mach. If you've ever heard of Mach speed, when applied to the speed of sound, Mach 1 means the speed of sound, and Mach 2 is twice the speed of sound, and so on. Well, the name MACH comes from Ernst Mach, who is the one who tried to explain the Newton's bucket experiment by saying it's the Earth and the distant stars that are affecting the water by exerting a force of inertia on it. And this is what is called Mach's principle. And there are physicists today who believe this, even though it is so vague and untestable that it shouldn't even be considered. In fact, even Wikipedia, if you look up Mach's principle, says that it's too vague and uncertain to be defined. Like I said, though, there are many people who claim that this is explained by Mach's principle. In other words, in some way, the stars, by some force, which isn't gravity, but some force of inertia, is causing the laws of physics on the rotating bucket to be invalid. So we have a problem for Newton and for all the physicists who followed. How do I explain why the rotating bucket does not obey the laws of physics? Newton said that the reason is there's a mathematical space called absolute space where everything is at rest. Well, no, excuse me. There is a frame in which everything is at rest that obeys the laws of physics. But if you are in motion with respect to that absolute space, then the laws of physics will not be valid. The problem with that is he never said where that absolute space is. It's a mathematical concept, which means it doesn't exist in the real world. And if you ask, where should I put my instruments in order to measure the absolute space, he couldn't tell you. So it was a way of explaining it using mathematics, but having no way of verifying it using the scientific method. So that has been a puzzle, actually, for how long? 3.5 centuries. And there has been no real answer to why do the laws of physics only be obeyed when you're on the Earth. But if you're moving with respect to the Earth, like the rotating bucket, or even if you're orbiting, if you do experiments on the moon or on the International Space Station, you'll find that the laws of physics are not valid. You'll be like the bucketeer. You'll find that the laws are not obeyed. So my solution to this is to say that the Earth is a fixed absolute frame of reference. It's the only frame in which the laws of physics are obeyed. This is contrary to all of relativity, which says that any reference frame is valid, even though we've known for 3.5 centuries, based on the Newton's bucket experiment, that this is not true, that the laws of physics are not valid on a rotating or moving frame, any reference frame that's moving with respect to the Earth. Now, physicists hate this interpretation that the Earth has a primary position in the universe. You could go back to Carl Sagan, who was a famous scientist and was very popular about 50 or maybe 40 years ago. He's on Johnny Carson. He wrote many books. And of course, he had what is called the cosmological principle, which says that the Earth is nothing special. It's just a little tiny speck in a vast, infinite universe. And that's called the cosmological principle, which says that there is no preferred location in the universe. Even though the Newton's bucket experiment shows that the laws of physics are only valid when you're on Earth, when you're stationary on Earth. Even if you were moving in a car or a plane or riding a bike, and you took measurements in those moving frames, you would find that the laws of physics are worthless. They're not valid. Despite the overwhelming evidence, there's an overwhelming number of mainstream physicists who deny that the Earth has this privileged position in the universe. And of course, this position has religious overtones because the Bible says that the Earth is the center of creation. Okay, why is it the center of creation? Because that's where God's children are. That's basically the reason. But that is in opposition to what is presumed to be a science which is free of religious thought. So there is definitely a thought process in the modern world which says that anything religious is not scientific. And yet we see that if we use religious principles like the Bible agrees with Newton's law, with the result, I should say, of the Newton's bucket experiment. Now, this is a terrific break with what is belief today. I've known this for about 20 years, and yet I still can't get a group that understands the significance of this observation. And
well, you mean a group within the scientific community, right? Because you got like 200 people in here that completely understand where you're coming from, Dr. Bennett. I promise you that.
Yeah, well, I meant in the scientific community, because to tell you the truth, a typical cross of America would not be interested in this at all, right? They wouldn't be interested in hearing about Newton's bucket. So you have to have at least some scientific interest in order to accept and to understand what this concept is.
That's interesting that you say that, Dr. Bennett, because we've had other PhDs that came to Flat Earth Fridays. We articulated our position, and it's true what you say. If they don't have an interest, even if the information is valid, it won't be acknowledged. That's just my experience, as a few other people's experience. In the space every single week, and it's just interesting, that you highlight that. The other interesting thing that you said, and I want to make sure that I slow that down for the audience, is, all of, physics is done from Earth, yet they say that it applies to all the universe, right? But then it doesn't.
Yep.
So I don't know if you could just expand on that just a little bit more, because I really want that to sink in with people, because that's what a lot of I'm just going to say the scientific community, just for general terms, they rely on, physics this, physics that, measurement this, measurement that. But then when it breaks down, they incorporate these abstract concepts, or they divert to different forms or different fundamentals of physics. When to my estimation, me being not part of the scientific community, I don't have a credential, I would think that the scientific community should be working towards physics that is applied to all scales, no matter where you are. What do you say about that?
Yeah, the attitude of mainstream is to go along and get along. All right, that is, if you worked if you were a teacher, let's say, in a university, and you accepted the ideas that I just presented, that the Earth is a privileged reference frame, and the only frame in which you can actually apply the laws of physics. And by the way, it applies to Maxwell's laws too, the laws of electrodynamics. In fact, any law that's generated by what is called the Lagrangian, but that's going deeper into physics. Why they resist, I don't know. You could look at politics, right? Why don't more people get involved in politics? Because it's the government that decides, how you're going to live your life. And why aren't people more interested in science? Because it's the technology that comes from the science that determines a lot of the things that change our lives. Just look at what we're talking over now. We're talking over the internet, which didn't even exist 30 years ago. And we're walking around with phones that have more computing power than the huge IBM 360 that I used when I first started on programming. So I guess you get into human nature to try and explain that, and that's above my pay grade. I try to stick to physics, and I have enough opposition from mainstream to try and deal with that.
Yeah, I bet you're probably like their worst nightmare. Me and Proud, my co-host, we talk about this all the time. Like, if we had credentials, we'd probably be terrorizing the scientific community with all, the physics, the science, the papers, or whatever they appeal to. Whenever we're trying to have just like a cordial discussion, in these spaces, they always start appealing to like academia, right? And it's just like, that's separate from science. I'm not going to say that there isn't a useful use case for, academia, but to me, that those are separate things. But yeah, you probably are met with a lot of backlash or pushback because this isn't mainstream information. Like, this is something quote unquote fringe, and usually they'll categorize these type of ideas as quacks or something like that, just so they could dismiss the information. And I think that's fallacious in itself.
Yeah, you know what a paradigm shift is? It's a change from one way of thinking to another. So we're talking about a paradigm shift here. Can we get people to understand that the Earth really is the only reference frame in which you can apply the laws, and in any other frame, the laws are invalid? Well, let's try to. I lost my train of thought now. I wanted to get some point across.
Oh, we were just talking about mainstream pushback.
Yeah, in your case, as in mine, you're trying to change the mind of a significant number of people, right? And there is a book written that explains what are the different steps in a paradigm shift. when you first go against the mainstream thinking, what you do is usually get ignored. Okay, so you, in your flat earth point of view, and myself in my uniqueness of the earth frame point of view, are trying to change what the majority of the people think. And the typical reaction to that is to be ignored. Okay, just ignore them and they'll go away. Then the next step, I think, is that there is a violent reaction. When they see that you don't go away, there is a violent reaction to try and squelch the opposition. And I haven't had a violent reaction because my point of view is not that well known. But perhaps you can address that from your point of view.
Oh yeah, you should see my replies, Dr. Bennett. You haven't been active on Twitter like that, so thank goodness your replies, your mentions, your notifications are safe. But if you start talking about this type of thing in front of the masses, where people are heavily invested for some reason into a specific worldview that was given to them, oh my goodness, you are going to be met with backlash, insults, just derogatory remarks, and none of it will address any of the points with specificity when we're trying to have the conversation. So yeah, we're very familiar with that behavior from the other side, unfortunately.
Yeah, I'm only at the first stage. I'm at the stage where I'm being ignored. Okay, you're probably at the second stage where you're getting a counter reaction in trying to shut you up.
Oh, is that what you call a whole
group of
group
is very
groupies?
Interesting.
Sorry.
Because if you have the truth, it finally will be accepted when a whole generation dies out. In my example with science, all of the people who oppose me or oppose my idea, if I can promote it long enough to younger people, eventually the older generation of mainstream will die out. And the younger generation, which is more open to new ideas, will be more likely to accept it. And you know what happens then? What happens then is everyone accepts it as though it was always true. In other words, they totally forget that they once opposed it, and now they accept it. I mean, you could take something like they once believed the moon was made of what, blue cheese. And then, just take that as an example. And then when they finally found out that the moon is made of the same basic material as the Earth, then that was accepted as though it had been always believed. So if you're successful with the flat Earth theory, eventually it maybe take a generation or two, but you may get a majority of the people to believe. Of course, there's plenty of examples where theories which are not true, of course, should not be successful. But it's interesting how people will change their attitude as time goes on if they are exposed to the truth. And eventually, I think truth will win out.
You'd hope so, right? If you put truth out there, people who are objective will find it, regardless of the people trying to obfuscate it. And when you say there's a direct reaction, would you say like a whole community of people who had sprung up to directly oppose everything we do, no matter where we do it? Would that be a direct reaction you'd be considering?
We still connected?
Oh, we can't hear me.
Oh, can you not hear Shane talking? That's just another bug of Elon's contraption that we're on right here. Don't know how to resolve that one. But Shane was asking you a question. I don't think I can compress it for you. Want to try again, Shane?
I would say Shane should drop down, and then maybe we'll try that.
Yeah, that's the deal. He's already gone. So when he comes back, he'll ask his question again, I guess.
Yeah, I think he was. I think he was asking about the reaction. You know, when people dedicate, all of their time and energy into one thing.
How about now?
Maybe. Testing. Shane, can you hear?
I'm here, Adam.
Can you hear me?
I can hear you.
Yeah, I do.
Okay, cool. Go ahead, Shane.
Perfect.
Did I not go up and come down?
No, you're good. No, we can hear you, Brody. Oh, he can't hear us now.
Bring your mic up about 15% and you're good.
It's the classic double reverse.
So sometimes, Dr. Bennett, we have connection issues. I know we're relying on Elon Musk for our servers. So sometimes certain people won't hear each other. So we're just going to drop them down and bring them back up if they have a question. But Shane wants to ask something. Did he drop back down again? Hold on. Let me try to bring him up one more time to see if he can ask that question. And then we'll get back to what you were saying. And then we'll get to some of the other hands because I think a few other people want to ask you some things as well. But I don't want you to lose your thought.
I threw one up to the post for you there, Sacred, for Barbara Dan.
Thank you. Appreciate that. Proud, try bringing Shane back up if you can. Shane, testing.
I can't hear nothing when I come up to speak. So you can hear me. I can't hear anyone now. So just skip me.
Oh, no.
Well, I can hear you. Can Robert hear him?
No, I did hear him for a brief moments.
All right, we'll try to get Shane situated. Maybe I could try to cycle him back up here. I don't know if you had like a thought that you wanted to finish on, Dr. Bennett. If not, there's a few questions for you.
Well, maybe you'd be interested in a letter that I sent out to Brian Keating. He is a promoter of mainstream science, PhD out at San Diego. And he promotes a lot of instructions to everyone to send in questions. He encourages, I should say, questions from those who are interested in science to send them into him for his responses. So I decided to send them basically what I described to you, the problem with Newton's law when applied to Newton's bucket. Because either he believes in absolute space like Newton, or he tries to make sense of Mach's principle, which nobody really has been successful in doing, or he has some other theory. But I can almost guarantee that he's opposed to saying that the Earth has a privileged position in the universe. That is, if it's the only frame in which the laws of physics are valid, then it certainly is favored over all the other places in the universe where the laws of physics are not valid. So I sent that to him. That was 2 days ago. I also sent it to 7 other physicists to see what their reaction would be. And again, it was just an outline of Newton's bucket, just like I gave right now. And it'll be interesting if anybody even answers the question, even though some of them promote themselves as great instructors and explainers of of physics.
Dr. Bennett, so what happens with that? So when you send ideas, I'm guessing these are your colleagues. Are these people that you're cordial with, or are these people that you haven't talked to before? Like, how do you choose who to send what information to, and what do you expect to get back, if anything? Like, how does that work?
Well, some of them I'm familiar with, just from surfing the internet. Who, like, I'm sure you've heard of Neil in the Grass, My Son, right? You've heard of him. And you and Brian Greene, maybe you've heard of him. Brian Cox. Yeah. So there's another. Well, what I actually did was I put a Google search for who are the top, physics. What was the word I used? Promoters, I guess, online. And then I got their emails, and I sent the letters. The answer to do I know any of them? No, I don't. Nothing personal. In fact, what happened since I left Stevens, which is where I got my PhD, I haven't had any contact with the instructors there. Most of them have died since I left. And once you no longer have a position in an institution, a teaching institution like Harvard or Yale or Princeton, you don't have the ability to post your ideas on archive. Do you know what archive is? ARXIV?
.org.
.org, right? Yes. It's the place where professional documents are published, or pre-published, I should say. They're tested, in other words, before they're put into books or used for research. So I can't even publish there because it requires that you have credentials from an institution that's approved. So they have a sort of censorship, scientific censorship.
You don't say. Wow.
Yeah, you don't say. Yeah, so even if you have a PhD, if you don't have someone who can vouch for you, you can't publish on this. And it's only preprints. In other words, they put it there to test to see if anybody finds anything wrong with it. It's sort of like a general peer review. And you can't even take advantage of that, like I said, unless you have, you're part of the club. You belong to the institutions, or you have some friend that will who's a professor at an institution who will give you the credentials.
So even with you, with all your tenure and your credential, it would be a struggle for you to even get access for those to publish something in that archive.
Right. Wow. I publish on a much more open platform, which is Vixra, which is archived backwards. So on Vixra.org, they will accept anything. And so there's a lot of junk. There's a lot of, untested, wild theories. But it is like a public square, right? If you go to a public square, you can expect all kinds of opinions to be expressed. And that's basically what Vixra is. Archive is a filtered scientific platform for expressing your ideas.
See, I have a huge huge problem with that. Because again, you know, we've talked to other people with credentials. I mean, astrophysicists, particle physicists, nuclear physicists. They've all come to Flat Earth Fridays. Some don't stay too long, but some do come back. But we'll get gaslit. Like, you know, there's peer review, or why don't you go publish something, right? And then you'll have someone like Whitsitt or Alan or Toby, Shane, even my guy Indio from Discord. So they'll present these publications that are from these general, I guess you could call it, like how did you call it? Like a square, town square journal,
Public
like
square.
Yeah, public squares. Like anyone can publish, but then those same physicists who we want to look at the information will dismiss it based on where it was published. Say, oh, that journal or that publication is pay to play. Just like you said, it might be a little bit of junk here and there, but they'll just dismiss it all together. And it's like, well, hey, you know, if they can't, you know, get their information published in the right place due to this censorship, and they can only publish it over here, what other choice do they have? You're not leaving us any wiggle room to operate here if I can't publish it in a place where it's respected by you, Mr. Physicist, who's you know, ignoring everything that we're saying. And if we publish it over here where, you know, it might be alongside with other things that are maybe quote unquote junk or fringe ideas, then you won't respect it in that manner. So at what point can you get an idea across to the scientific community if you're not in that club?
Mm-hmm. Yeah. It's a small club and you're not in it. That's it.
My man, George
Carlin.
Carlin.
Carlin, I love it.
Yeah.
Yeah, it's super unfortunate. We're still here. We're probably gonna get to some hands real quick, and then maybe we can expand in some of these other models and concepts and ideas that you have. I was super interested in hearing you talk about alpha. Maybe we can get into that in a little bit. But just to close it off, just for the listeners, Dr. Bennett, before we get to some of the questions, can you just highlight the issue with Newton's bucket in relation to how we view the Earth, like our worldview and current mainstream science? Like, can you just highlight the contradiction or the contention? Maybe that's a better word, just for the audience one more time, because this may be new concepts for them. And I just want them to really hone in on this, because this is the reason why you said that you took your position as, you know, we're in a stationary frame. So if you could just give like a basic overview of just that whole thing, and then maybe we can take a few questions after that.
Okay. What I said about Carl Sagan is probably applicable to all of mainstream. They basically think that the Earth is nothing special, and again, that has religious overtones. It's a way of not accepting anything that they didn't think of. It's an elitist point of view, and it gives them control. I mean, all of this sounds like political rationale, but it also applies to science. They get a certain amount of respect if they all agree on a common body of knowledge, even if parts of that knowledge are false. Some of their beliefs can't be proven experimentally. Some of their interpretations are not logical. I gave a talk, I forget when it was, but it emphasized philosophy. The philosophy that underpins science is never stated officially. Scientists should believe that what is measured in the real world can be translated into a mental picture of the real world. In other words, that we can translate what we measure experimentally into what we believe as the laws that underpin the experiments, that predict the experiments. Okay, so a summary of the Newton's bucket is basically that there is a worldview that says that all points of view are valid for applying the laws of physics, that is dynamics. Newton's bucket proves that that is a false belief. It shows that the Earth is fixed because only using the laws of physics in the Earth frame can you correctly predict the result of the experiment. In any other frame that's moving with respect to the Earth, you cannot apply the laws of physics. You must separate this from kinematics, which is the branch of physics that does measurement. If you measure the way the water moves, that's kinematics. If you predict the way the water will move, that's dynamics. So kinematics is fine. You can use any reference frame to do measurements. In dynamics, however, you must use the Earth frame. Now, my abbreviated summary of this is called ALPHA. ALPHA means absolute lab frame, ALF. Okay? Absolute lab frame means that when you use dynamics, you must use the lab frame. The A part, or the FA part of alpha, means either fluid or flexible ether. If Newton's laws are not valid in a non-Earth frame, then how can you explain the motion of the cosmos, of all the objects in the universe, the planets, the moons, the stars? How can you explain them? Because Newton's law validly does that in the solar system. Newton's laws, in other words, are believable and workable in the solar system. But if you take the Earth as the center instead of the sun, then you must have some way of explaining how do all of these objects move without the laws of physics to support them, which you would use if you're not in the Earth frame. And the answer is, you can use this concept of ether, which represents a universal substance, the basic primal substance that exists everywhere. There is nowhere where it is not. And from that ether, you can build up a model that explains how everything moves. You can also explain how particles are formed by spinning vortices. We know that all particles at the elementary level are observed to have spin. So they're all spinning like little tops. We can explain that by the circulation of ether, called an ether vortex, that sustains it. We can also explain how they continue to spin without any extra influence from other objects around them by saying that there is an ether wind that is being supplied from outside the universe, which is part of what I call the Hildegard model, which I am presenting to the ether cosmology group, and we'll finish up on Monday, I hope. So alpha represents an ether model and an absolute lab frame. And as far as I know, I'm going to add H for Hildegard, because the Hildegard model that I'm talking about is consistent with everything that I've learned and developed in my own theories. So it extends it even more. And that sort of gives you an outline for all of my research interests right now. I also intend to investigate the experimental results of a Russian named Atsutaski, who wrote about 600 pages of experimental results, and they all concern measurements of the ether. And no one, to my knowledge, has looked at the English translation and converted it into a workable theory, a consistent theory that explains what Atsutaski measured. I hope that answers the question of what my research is and what Newton's bucket.
Atsutaski is dense as heck, though. I wish somebody else would get through that and give us the summary already, don't you?
All right, fine, I'll do it.
I don't know if Bennett can hear you, Shane. Bennett, can you hear Shane?
I'm thinking that's a no.
Oh, did we lose Bennett?
Actually, I think we did, and we lost him on the net in general. I had him up in the Discord server still, and he seems to have dropped from there too. So yeah, he's gonna have to restart his browser at the very least at this point. So give him about 90 seconds, I imagine he might be back.
Oh no! Let's see if we can get sound like it was a issue on his end. Let's see if we can rotate him back up because I did want to comment on something, and we
got about 4 hands in the air there too.
Oh, so I only see 2. Oh no, I'm glitching.
I
all right.
see 2 as well.
Yeah, the 4 being Superfly, Jonathan, Orwellian, and Run Boston, our El Presidente.
Oh, you're glitching, bro. Orwellian and Run Boston not even up here.
Thanks, Elon.
Space-time spaces. Okay, let's do. While we get Dr. Bennett back up here, let's slide over to Superfly real quick. And if it is a question for Dr. Bennett, we'll just have him repeat it once we get him back. Although I do want to say, and I'm probably going to repeat this when Bennett comes back, but notice, I'm sorry, y'all. Just notice that he's using the same words that Whitsitt uses, while everyone Gaslight was talking about is word salad. You heard centrifugal, centripetal. You heard the convergence. That you heard all these different things that Whitsitt be saying all the time, and here you are. You hear the PhD physicist using the same vocabulary. Okay,
Yeah,
I'm
but
just highlighting that.
Purdue's word salad, though, so.
You know, it's crazy. We're talking about the dynamics and the fundamentals of, you know, the ether and in general, his belief. And all the Globers, all they want to know is whether he thinks it's flat or round.
Every single one, guaranteed. That'll be the extent of their
all
interaction
they care about.
with this
That
whole
is
thing. Yep.
crazy. Just spy. I'm seeing it too. I just don't even want to get into it just yet. We'll probably end it there. But like, yeah, that's all they care about, because it's just an easy way to deflect away from the information that we're presenting. Being that the ether is a more viable option than your dark energy and dark matter, no matter how spherical you think your Earth is, my brothers. Sorry. Anyway,
they will go through a reference on motion that's for its use. It is to prove that it doesn't move. And they'll be like, their conclusion, yeah, but he doesn't think it's flat. Right? So you're a retard. Crazy.
I bet you they won't want to talk about motion. I bet you don't want to talk about that. Anyway, Superfly, you there?
Yeah, I am. You know, Sacred, thank you for having this. And I know I bugged you this morning. I said, hey, are you going to do any Flood Earth Friday? You know, but listen.
Every week, man, you know we pulling up.
I know, but it's me. I didn't see nothing, so I didn't see nothing coming, so it's my fault. Look, I didn't have a question for Dr. Bennett, but he opened my eyes. You know, when you do my job, the job I used to do before, I retired from 28 years of working as a corporate pilot. Okay, I couldn't spit the stuff out. I lose my job. So when I learned that, when I caught on to, and I got excited because I knew that I lived on a flat earth. Now, I mean, I lived on an immovable earth. Why? Because at one time I was a, hellacious Christian, and and I still believe in God, and God says that it's immovable. God says that we live, that we have a, we live like in a tent. Um, and now we got this Dr. Bennett telling us that, hey, listen, it's immovable. It doesn't move. That's good enough for me. Yeah, you want to put me on a globe Earth, but now if we don't move, that's great. Now we're just kicking the shit out of these freaking scientists and astrophysicists and all these people that say that we move at 1,000 miles an hour. Well, I wanted to tell Dr. Bennett, well, what do you think about Felix Baumberger that went up to 127,000 feet, 24 miles up, and then came down and landed only 25 miles away from his where he took off from? Hello? Are we fucking spinning at 1,000 miles an hour? Hello?
More
I
so
don't think so. I'll land right there with that.
He landed 25 miles to the east of where he started from.
Exactly. That's that part. Anyways, I just want to say thank you to everybody for listening to my little rant. But Sacred, love you, brother, and everybody else here for at least we're a force to not be reckoned with. You know what I'm saying? We are a unique kind of people, and let me tell you, I wish I would have lost my job a long time ago if I would have said I'm a flat earther. Because that you just don't answer those questions. You look like a fucking fool, being a pilot and everything in uniform, and then you're a flat earther. You get the hell out of here. But now it's a little bit more common. There's a lot more pilots now that'll tell you, that work for the airlines. They'll say, yeah, I think it's flat. I shot a picture out to you there, Sacred, of one of the cockpits I was working under. Hey, listen, I'll talk to you guys later.
Yo, shout out to you, Superfly, man. It's always good to hear from you. I'm just getting so much chills just listening to this conversation this evening. I mean, only because like I hear all the time, oh, it's only you flat earthers, that there's no such thing as, a pilot or whatever the case is that's a flat earther. Then you have someone that literally worked with the DOD. Like, it's like, come on, y'all. Like, he's telling you what happens when you in it. You can't really talk. You heard Bennett say it. You can't. There's censorship within these fields of study, and they want to make it. But they want to have you believe that it's just all open, it's all transparent. Like anybody could just present anything, and like, no, bro, that is not how it works. And the fact that we keep hearing this in 2024 from the average anti-flat earther or just the layman who doesn't understand the highest level of physics or how academia works. It's just refreshing to hear this from people with credentials, and I really appreciate y'all honesty. It's just unfortunate that if you guys aren't in your profession, you can't talk about it while in your profession. Like, that's the only thing, because that's always going to hold us back. If we can't have like the best and brightest minds speak about what they really want to speak about, it's just not going to help us. It's going to keep on holding society back. Imagine where we could be if we could speak freely and be accepted with all the ideas are more accepted, right? They're taken more seriously than just dismissed. So I appreciate you sharing that, Fly.
It makes me wonder if some of the pushback we get from some of these PhDs, some of these credentialed people, is because they know they can't talk about it. It is because they know they can't discuss it. And if, their job, if their credentials got wind of them talking about this type of thing, they could potentially lose that position in science. So it makes me wonder if there is a correlation between all the pushback and the hate that we get for a reason.
Absolutely. That is a real good point, bro.
Welcome back, Cassandra.
I'm on a screen I don't recognize, but I hear the voice.
We hear you nonetheless. Looking good.
Nice. It somehow worked out.
Are you on desktop or mobile?
Desktop.
There should be like a window. How does it look, Alan? Is it like a little window on the right side?
Oh yeah,
That will open up.
So there'll be a little window on the bottom right hand side, and it might be minimized, so it'll be like a little sub bar on the bottom right, and then if you click that, it'll pop up the big window so you can see everybody again.
Oh, yeah. Well,
it shows Sacred's name.
What I see now is the Atsutowski reference.
Oh,
with Alan. Alan's.
Yeah, that's the very top of the Spaces pop-up.
Yeah.
If you mouse wheel down, you'll see us. You should be able to see us. We're under that.
So what you're looking at?
Okay.
Yeah, what you're looking at, Dr. Bennett, is when we're in Spaces. One of the only greatest features that I guess we have in sharing content is it's called the Nest. Some people call it the Jumbotron. So what we do is you can tweet things out, and then we can share it to the top of the space. So that way people can get visuals of some of the things that are being discussed. And it'll be like a bunch of tweets that are being shared. And anyone that's on a mic, not listeners, but anyone that's on a mic can share content to the top of the space. So as you're talking, some of the guys are just sharing some of the information that you were speaking about, so that the listeners can have like a visual with the words.
Mm-hmm.
So, and when you get more familiar with Spaces, we could walk you through how to do that, because you'll probably want to share some of your own content if you start engaging in these spaces more often. So, and it's real simple, but that's what you were looking at. That's just the shared content up top.
Wow, a lot of people here.
Yeah, a lot of support, man. We've been waiting for you to show up, so it's really good that you're here, man. Appreciate you.
Wow.
And we're getting a lot of feedback, so we're gonna get to some of these questions. I'm looking at my notifications. There's a few comments. We have Jonathan with his hand up. Jonathan, you have something for Dr. Bennett?
Yeah, I had a question about the bucket experiment and reference frames.
Go for it.
So I was listening to you talk, Dr. Bennett, and thank you for coming on here, by the way, and sharing. So I was thinking about how the laws of, I guess, Newton do not hold in a rotating reference frame, like you pointed out. So sitting on the edge of that bucket, you're not going to be able to rely on equations, even though you look around that bucket and it seems to be stationary with respect to you. So that's a very valid point. I follow that. So then my question is this: when I'm on a train, let's say that's going on a straight track, maybe it's a maglev, really smooth, very fast train, and I'm standing there in the middle of the aisle and I'm juggling 3 tennis balls. Well, as soon as that maglev starts to make a turn, and let's say from that point on, it's taking a turn of a constant radius from that point on. Now it's going in circles. So now I'm going to feel that centrifugal force on me, and so now the algorithms in my brain that I've trained since childhood, that basically do all those Newtonian equations for me organically. They're being messed with now, and they're no longer able to predict as well. And now I'm losing my orientation and I'm dropping these tennis balls. So the point is, I do remember being taught that as long as you're in an inertial reference frame, I believe is what they call it. So you're going in a straight line at a constant velocity, or you're going zero with respect to some other frame. As long as it's that constant straight line type of frame, then you have that equivalency, and you can juggle no problem. You can do a little science experiment where you launch a ball and then predict its parabola and where it'll land, all that stuff, and that can work on that maglev train going in a straight line. Is that not a valid distinction?
Yeah, Jonathan, we have to distinguish between whether you're measuring what you should do or you're predicting what you should do as you juggle the balls, right?
I guess we're predicting, yeah.
Okay, if you're predicting, then you must use the Earth's frame to correctly predict what you're doing. Let's forget about the turn. Let's just take the train moving at constant speed, right? Which is, according to the special theory of relativity, that is an inertial frame. But it is
Right.
that's not an inertial frame according to the definition I presented, which is that you must be in the Earth's frame. In other words, you must be standing on the tracks or on a station platform, stationary, in order to predict what will happen to the ball that you're juggling. Okay? If you try and use the reference frame,
I'm listening.
Okay, the train in constant motion is an inertial frame according to relativity, but it is not according to the definition I gave. Why? Because the train is moving relative to the Earth. Okay, just like the bucket water is rotating relative to the Earth. So if you're going to predict what happens in the frame in which the train is moving at constant speed, you have to observe the laws of momentum. You have to apply that is, you think you're in a stationary frame. You have to apply the laws that apply for a moving frame as compared to someone who's seeing this in the Earth frame on a train platform. So the difference is that there would be a difference in energy, basically, between what you see on the platform, which is the Earth preferred frame, and what you would measure in the train frame, which would be zero energy. So if we measure the energy, we find out that it's the measurement on the Earth frame that is valid, not on the Earth, not in the train frame, because in the train frame, the ball is moving along with you. It has no energy. But from the train platform, it does have energy. So the difference between the two can be measured, and only the one on the station platform will correctly measure the energy. There's other ways of doing it, but then I have to describe the forces that are on the ball, ignoring air friction, and only taking into account gravity, basically. And if you include the turn that the train makes, well, then that's another force that has to be considered. But if you consider just from point of energy, which is a law of physics, by the way, conservation of energy, that's violated on the train, but not on the station platform.
I guess the conservation of energy would be like let's say you pick your frame as the Earth or the train. I guess as long as you stay consistent with that choice, then from that point on, you apply the law of conservation of energy, and you should get the right answer. That was my understanding of conservation of energy. It's kind of like when you're working a circuit on paper, you choose what's ground. In some cases, it's arbitrary. Mm-hmm. And then you go from there, and you have to maintain and stay consistent with your choice. And then if you stay consistent, you get the right answer, assuming you don't make a mistake elsewhere. So that's kind of, and you've gone way further into academia than I ever have. So I'm not trying to question that, but I'm presenting to you how I learned it, and kind of how I understand it, and seeing if I understand you correctly when you speak of a contradiction And so just to reiterate real quick, you were saying that if you're on one of these other reference frames that isn't the Earth, that the laws of Newton no longer give you the correct answer? Is that?
Yeah, that includes conservation of energy, angular momentum. Maybe, Jonathan, I could give you a simpler example. Suppose you're riding a bike, and the bike is you come to a down ramp, and the ramp is a height h above the lower level. So you have two levels: the bike on the higher level, the lower level, separated by a height h. Okay. If you have conservation of energy, then the potential energy is mgh. That's the weight times the height, plus 1/2 mv squared, right? Which is the speed of the bicycle. That's the total energy of the bicycle in the Earth frame, right? So you're looking at a bike that's about to go down a ramp. The energy is 1/2 mv squared plus mgh when it's at the higher level. The bike goes down the ramp. Now it's at a lower level. H is 0. And the energy that we calculate, total energy, is just 1/2 mv prime squared, where v is the new speed of the bike on the lower level. If we compare the two, let's see, we have the mass of the bicycle canceling out. There's an m on both sides of the equation. And this is the Earth's point of view, because we're using an upper and a lower level. If we calculate the energy, the total energy before and after, we predict that there will be a greater speed at the bottom because we have the extra factor of mgh. Now, if you're on the bicycle, what you calculate is a difference in the mass of the Earth, which is moving beneath you. Remember, if you're on the bike, you consider that as a stationary frame. So if you're on the bike and using that as your reference frame, then the bike is at rest. You go down the incline, and in order to do that, the Earth has to move minus h, has to drop and lose potential energy. And when you calculate it, you get that the energy depends on the mass of the Earth, which is totally wrong, because the calculation, when we make it from the point of view of the Earth frame, correctly predicts what the speed of the bike will be when it's at the lower level, when it goes down the ramp.
Maybe I agree.
Yeah. And
so you're saying that if you attach the original reference frame at time 0 to the bicycle and the rider at the top of the hill,
right?
Now, to keep that one consistent, that reference frame is going down at v0, which whatever velocity he started with, and the frame itself continues down at that sloped angle in a straight line throughout time. And so he's speeding up, and he's essentially leaving his original reference frame as he speeds up.
No, the reference frame must always be 0, okay? You must always consider yourself at rest. So if you're on the bike, what you do, you see the Earth, the road, moving towards you, right?
Yeah, the bottom of the incline is moving towards you. The Earth is moving towards you.
Yeah, if you were driving in a car and you said, okay, the car is at rest, then that means that the road itself is moving towards you underneath the car, right?
Right.
Okay, so if we actually measured from the bike, what is the motion of the Earth? It would be equal to the speed of the bike, but in the opposite direction.
Right.
Okay, when you go down the ramp, the same thing. It's as though the Earth came up to meet you, but the bike stays stationary. Okay?
Yeah, and the Earth would be actually accelerating up towards you.
Exactly. And then when you reach the bottom level and continue in a horizontal, then again, the Earth is moving underneath the bike. Okay?
Right.
Okay, you have the idea then. The correct interpretation is if the bike is stationary, which is a frame different from the Earth frame, then what you predict depends on the mass of the Earth. Okay, the same equation holds, except the m in the equation is the mass of the Earth, not the mass of the bicycle. And if you use that, then you get a ridiculous result that says there's an enormous amount of energy available just when you go down the ramp, because you're moving the Earth by a distance of h. It all comes out in the math, but I'm trying to talk my way through the math.
Yeah, and I don't have a piece of paper in front of me, but I do follow it. It's a fairly rudimentary. It's like the first, one of the first examples I gave you in physics class. So, and it is fun to think of it in reverse like that. But back to the reference frame though. We disagreed on what the reference frame is if you're the bike, and if it's an inertial. I guess my point was if we're thinking of inertial reference frames, then that reference frame can't accelerate, otherwise it ceases to be inertial, right?
Yes. The inertial frame is, the reference frame is whatever the observer state of motion is. All right. Whoever's doing the measurement is at rest by definition. Because think of the contradiction. If you said, okay, I'm moving at 20 meters per second, well then the question is relative to what, right? Whatever you're moving at 20 meters per second to is your true reference frame. Right?
So do we agree that the bicyclist is not representing an inertial reference frame?
Not according to my definition. Anything in motion with respect to the Earth is not an inertial frame. In other words, the only inertial frame in the universe is the Earth.
Okay, that's interesting.
Yeah, I think maybe I could summarize it. At the top, at the upper level, the equation is 1/2 mv squared plus mgh. Okay, and at the lower level, there's no more h, it's just mv squared over 2, but the v is v prime because you have a new speed, right? You have a greater speed when you go down the ramp.
Right.
Now, in those equations, the m, when you use the Earth frame, the m stands for the mass of the bicycle, because that's what you're measuring. When you're in the bike frame, the Earth is the reference frame, so you use the mass of the Earth. And you get a ridiculous answer. You get, megajoules of energy, because the mass of the Earth is included.
I'll have to think on that. That's thank you for sharing that with me, and I'll be thinking about that. And if you're back next time, then I'll give you kind of a summary of what I think after I've hashed out all my thoughts, because my thoughts are kind of swirling, and that's pretty cool. Thank you for sharing that.
Well, Jonathan, you can always get me at my email.
I would like that.
Okay, it's robert.bennett
Well, don't share it here, but I will.
Okay.
I will follow you, and then I'll ask you in a DM.
All right. All right. Thanks for the question.
I appreciate it. Thank you.